right, our next task is to write equations with some special requirements. We're going to go back to parallel and perpendicular lines, and then also our horizontal and vertical lines. So I have put in the reminder here about our about our slopes and ordered pairs for both horizontal and vertical lines, the ones that we talked about earlier. Remember, an equation for a horizontal line looks like y equals b. In every y position in the ordered pairs on a horizontal line, you'll see the same number. Slopes will be 0. Vertical lines, x equals a. In the x position of every ordered pair on a vertical line, you'll see that a, and the vertical line's slope is undefined. Now remember, when we have parallel lines, we have same slopes. That's what we're going to need for those. And then with perpendicular lines, we have negative reciprocal slopes, and that's what we're going to need with those. So if we have m, then the perpendicular slope is negative 1 over m. And so now that with that reviewed, we'll go ahead and we'll take a look at example number 24. Example number 24, we're going to go parallel to the line y equals 2/3 x plus 9. And so what that's telling us about is our slope. So now we know that we have a slope that is the exact same slope as that one, 2/3, and it's through this point. Notice that this is not 0, so that's not our y-intercept. So we're going to say y minus our y-coordinate equals our slope, 2/3, times x minus our x-coordinate, negative 9. And then we'll go ahead and we'll simplify that. So you'll notice with the parallel perpendicular given, what we're getting from that information is the slope of our line. So y equals negative 7, 2/3 times x, which is 2/3 x, and then 2/3 times a positive 9. 3 will go into 9 3 times 2, which is 6. And then moving the 7 over and the 7 over, adding 7 to both sides, y is equal to 2/3 x, and then plus 6 plus 7, which is equal to 13. And again, we could check to see if our ordered pair satisfies this. All right, moving on to the second one. We are told that we want a perpendicular. If you haven't seen this before, right, perpendicular, I do an upside down T to show perpendicular, to 2x plus y equals 3. So we're going to have to use our skills here to put this in slope-intercept form. So we're going to be moving this 2x over to the other side by adding its opposite. So we're going to have y is equal to negative 2x plus 3. And so that's going to tell us that our slope needs to be the negative reciprocal of what we see here. So that's going to be a positive, and the reciprocal of 2 is equal to 1/2. So that's our slope. This is our our point. It is not a y-intercept point because x is not 0. So now we're going to plug into our point slope form. Y minus the y-coordinate here, which is a negative 3, and then equals, and our slope, which is a 1/2, because this is the slope of the line that's perpendicular, right, our line, times x minus, and then the x-coordinate, which is 4, right there. And now we're going to do distributive property here and here. So y plus 3 is equal to 1/2 times x, which is 1/2, and then minus 1/2 of 4, which is 2, and then add the opposite of 3 to both sides. So y is equal to 1/2 x minus 5. And again, if we want to make sure it satisfies, we put in our ordered pair and check and see if it's true. So 4 times 1/2 is 2, and 2 minus 5 is a negative 3. Bingo, it's the check, and it satisfies. So those are parallel and perpendicular. In the next video, we're going to do some more of those, but we're going to throw in our horizontal and vertical requirements as well. So we're going to still see parallel, perpendicular, but we're also going to see horizontal and vertical. And so that's going back to those particulars that I had outlined for us back here on this page. So I will see you in a second.